All right, we're going to continue with day 2 of special right triangles and unit circles. So if you remember, we just kind of touched base on the sine, cosine, tangent, how to find the values, and then just barely did a little bit with creating a table. So one thing I want to go over is now we're going to be finding these exact values for sine, tangent, and cosine, and they'll be in degrees or they'll be in radians. There's 2 ways to do this. The first way involves memorizing this unit circle, which I did attach to one of the PDFs. But you can see the points, there's quite a lot of them. They're pretty much the same values. Like here you've got rad 2 over 2, and here you have it, but different signs, positive and negative for different angles depending on which quadrant. So what I like to do instead, I prefer to just memorize the first quadrant. And I have a nice little trick for that, so I'm going to show you that. So we're going to start in the margin. So this is helping to memorize quadrant 1 of the unit circle. And if I go too fast, feel free to stop, rewind, oh goodness, stop and play it back. So what we're going to do is for unit 1, or for unit circle quadrant 1, we have 30 degrees, 45 degrees, and 60 degrees. And the way this works is, and again, this is a little shortcut, you're going to basically write a 3, a 2, a 1, and then on the other side write a 1, a 2, and a 3. These are all going to be numerators, and then you're going to write them all over 2. So we did 3, 2, 1, 1, 2, 3. Now give everybody a denominator of 2, and then you're going to square root the top. So square root of 3, we don't know. Square root of 1 is just 1, so we're going to leave it. You're going to square root these, leave them. Square root of 1, again, we know is just 1, but square root of 3 is not. Put a comma in between. These are going to be your ordered pairs. And we're going to refer to this many times. I personally would put this on a note card because you're going to need it for homework for this week and for next week. This first value here, we talked just briefly. This is your cosine of theta. This y value is your sine of theta. And in order to find tangent of theta, you're going to do sine theta divided by cosine theta, and then you'll reduce it. So that's the little trick that we're going to use. The other little trick that we're going to use is for the signs in the different quadrants. So this is the sign rules. Again, I would recommend making a note card. Like I said, that's what I'm going to refer back to. For the sign rules, if we look at the 4 different quadrants, here's quad 1, quad 2, quad 3, and quad 4. There's a saying, it says all students take calculus. Let me write that down here. All students take calculus. And basically the first letter, the A, the S, the T, and the C, those are going to denote the positive values for sine, cosine, and tangent. So it works like this. So you're going to do all students take calculus. So in this first quadrant, the ones that are positive are sine, cosine, and tangent. So sine is positive, cosine is positive, and tangent is also positive. For quadrant 2, only sine is positive. So when you know that only sine is going to be positive, that means cosine's negative and tangent's negative. And then tangent is the only one that is going to be positive. So that means sine is negative, cosine negative, tangent's positive. C stands for cosine. So sine is negative, cosine is positive, and tangent is negative. So with these 2 pieces of information, we will be able to figure out these different answers. without having to memorize the entire unit circle. Back up here, just really quickly, wanted to go over the common radians that you really should just kind of have memorized. And it's just for first quadrant. So the common radians are pi over 6. That's the same as 30 degrees. Pi over 4 is equal to 45 degrees. Pi over 3 is equal to 60 degrees. And those are probably the basic ones we need to want to make sure we know. All right, so I'm going to write it out very step-oriented for the first couple problems, and then we'll go from there. So the first thing we want to do, we want to find out what quadrant this 4 pi over 3 is in. So that's always our first step, is to find the quadrant that it starts in. So 4 pi over 3, if you don't remember, so let me just do a quick little sketch. Here's 0, this is pi over 2, this is pi, 3 pi over 2. 4 pi over 3 is more than pi, but less than 3 over 2, so it's going to be somewhere down here, and it doesn't need to be exact. So that is 1, 2, 3, so we know we're talking about quadrant 3. And the reason we want to know this quadrant 3 is because the next step is to figure out what the sign is in quadrant 3. So for quadrant 3, only tangent's going to be positive. So if I'm trying to figure out the value of sine, I know that my sine value is going to be negative. The next thing we're going to do is we're going to find the reference angle. So we're going to basically go back to the first quadrant and find the reference angle, so that way we don't have to memorize more. And this is what we did last week. So if you remember the reference angles, so we're in quadrant 3. So quadrant 3 says that we're going to do theta minus pi, and that's going to give us our reference angle. So we'll be back in quadrant 1. Again, note cards are very helpful. So we're going to do 4 pi over 3 minus pi. Make sure to have common denominators. So if I put this over 1 times top and bottom by 3, so I get 4 pi over 3 minus 3 pi over 3, so that just leaves me with pi over 3. And now pi over 3 is just 60 degrees. So this is exactly like 60 degrees. So 60 degrees, I go back up here, 60 degrees. I'm looking for sine. Sine is going to be radical 3 over 2. So we just want the y value, but it should have a negative in front because of the quadrant. So the answer is that sine of 4 pi over 3 is equal to negative radical 3 over 2. Let's try another one. Let's try tangent. I went over my spacing, sorry about that. So we're going to do the same steps. So first, find the quadrant. So 150 degrees is a little bit easier than radians, so hopefully you know 150, that's in quadrant 2. Okay, and again, you know that because if this is 90, this is 180, 150 is here in quadrant 2. Your sine in quadrant 2 of tangent, so if we go back to our sine rules, sine is going to be positive in quadrant 2, that's leaving tangent to be negative. So I know I'm going to end up with a tangent that's negative. You want to find the reference angle from quadrant 2. So if I go back to my post-it note, quadrant 2, I'm going to do 180 minus theta. So I'm going to do 180 minus 150, which is going to give me 30 degrees. Then I take my 30 degrees. I want tangent, so we know tangent is sine over cosine. So tangent of 150 degrees is going to be sine, and again, we're using the reference angle so we don't have to memorize all the unit circle. So sine of 30 is 1/2. So it's going to be 1/2 over, and then I know tangent of 30 is radical 3 over 2, and it's negative. For simplification purposes, you can just cancel both the denominators here. So I can go ahead and cross off the 2's. But I'm still left with a little bit of a problem because I've got a 1 over a negative radical 3. You cannot have a radical in the denominator, so multiply top and bottom times radical 3. So this is going to give me radical 3, I'm going to put the negative up there, over 3. So my tangent of 150 degrees is negative rad 3 over 3. So this process does not change. We continue the same process as we go through and work out the problems. So let's go ahead and do cosine of 11 pi over 6. And then I actually, after this, will create a second video just because this one's getting pretty long. So 11 pi over 6, again, go back to the radians here. 11 pi over 6, if you do 11 divided by 6 versus 3 divided by 2, 11 over 6 is bigger, so we know it's in quadrant 4. So I know I'm going to be talking about quadrant 4 here. And then for cosine, for quadrant 4 is positive because all students take calculus, so cosine is the only positive value, so I know my value is going to be positive. I need to find my reference angle, so I'm going to take this 11 pi over 6, it's in quadrant 4. If I go back to my note card for reference angles, I'm going to do 2 pi minus theta. So I'm going to do 2 pi minus 11 pi over 6. Change this, right? Times by 6 top and bottom. You're going to end up with 12 pi over 6 minus 11 pi over 6, which is just pi over 6. And then lastly, 11 pi over 6 is just a 30-degree angle. So if I go back to 30 degrees, I'm wanting cosine. Cosine is my first value, radical 3 over 2, and we know it's positive. So cosine of 11 pi over 6 is going to equal radical 3 over 2. Now just be careful because I know it's very easy just to glance at the unit circle, but I could give you values that are greater than 360 that are not on the unit circle, so you want to make sure that you're understanding this process.